everyone. My name is Raj. I'm from UC Berkeley. Very happy to be here today to present my research outcomes. So as you know, intelligent miniature robots have increasing demand in assisting rescue operations at very dangerous places. And our research intended to invent a fully autonomous quadcopter to meet this demand. And some of you maybe don't know what is quadcopter. Quadcopter is this. So quad means 4 propeller, and copter means helicopter. So quadcopter means 4 propeller. So I want to ask why my research and my project is valuable and unique. In order to answer this question, we need to compare our quadcopter with conventional quadcopter. So conventional quadcopters use multiple microcontrollers and sensors, for example, gyroscope and accelerometers. But our quadcopters use one vision sensor and one field programmable gate array FPGA to achieve fully autonomous control. So how our quadcopter works? Let me demonstrate. So because I don't have power supply, it's nothing dangerous. So, okay. So this is the image sensor, and at the back, it is FPGA chip. So when our quadcopter fly in the air, okay, the image sensor capture the image and sending image data to FPGA, okay, and the algorithm in FPGA processing that image data and generate very fast and accurate motor control speed to control the speed of these 4 motors at the same time. Okay, at the same time, it's very important. So this is means we need a chip, okay, that is capable to processing image data and motor control signals at the same time. So ordinary PC and microcontrollers cannot process that huge information in a very fast speed. But FPGA can process the image data and motor control signals in real time. What's real time? Real time means there is no delay for processing. It's really amazing. So as image data got processed by the algorithm in FPGA, the motor control signals will go through this motor control board, and it will change the speed. It will control the speed of these 4 quadcopters at the same time. And my work is to program this FPGA chip. I write the control algorithm, motor control algorithm in FPGA, and I design the motor control board to make our quadcopter fly in the air. So why do I need to program FPGA, and why do I need to make such a motor control board? So in my next slide, I will talk about it. Okay, so as you know, brushless motor is not DC motor. We cannot directly plug in a battery with brushless motor. That brushless motor doesn't operate in such simple way. We need control signals from FPGA to run brushless motor. It's not just it's not DC motor. We cannot directly use battery. It won't work. But our FPGA only output a 3.3 volt and 50 milliamperes. But brushless motor need to operate at 7.4 volt and at least 2 amperes to work. So we need something that we can amplify our FPGA programs, FPGA input signals from 3.3 to 7.4, and making this three-phase voltage shifting control signals to control our brushless motor. So how to do it? So I have my first version of this motor control board. My motor control board consists of 6 terminals, as you see the black thing, and each terminal is made of N-channel MOSFET. So the N-channel MOSFET act as switches. So my program in FPGA can switch on and off these 6 terminals in particular timing and in particular order to generate such complicated motor control signals. So how exactly we can do it? So I show the demo here. So for example, if terminal 1 and 6 is closed, the current will go through coil A and coil C. So at coil A, it will connect to the power supply. At coil C, it will connect to the ground. So because position A connected to power supply, it will generate 7.4 volt. And because position C connects to ground, so it becomes 0 volt. And coil B is between coil A and coil C. So the voltage of position B is half voltage between A and C. So we create 3.7 volt. So I just keep switching on and off, and I can form this three-phase voltage shifting control signals to control brushless motor. And because we have this FPGA, we can design a highly compact system with low power consumption. That means we can make the quadcopters very, very small and very light to do rescue work in very hazard places. So let's check out my performance. Final version of my motor control board. And this is the quadcopter. You can see the signal from at the back. My algorithm in this chip will calculate the present frequency and target frequency every time. So it's now accelerated.
Okay?
Yes. And you can see the signal. Okay,
Yes,
become very, very dense. And then now it's deaccelerating. You can see the signal over there, like stretch. So it becomes slowing down.
Slowing down.